Hello there. We are in the last lecture of week 9. What have we been doing for the past 2 weeks? If you remember, I've been doing syntax-based testing or mutation-based testing for the past 2 weeks. This sort of pretty much brings us to the end of the core of test case design algorithms that I wanted to teach you as a part of the course. At this point, we are done with 3/4 of the course. We have 3 more weeks of lectures pending, and it's a very good time to spend one video trying to look at what we learned from the beginning and where are we going to go from now. So that's what this lecture is going to capture. It's going to give you a summary of the course as it is after week 9. So in the beginning, when I started lecturing at the beginning of the semester, what did I commit to? I told you, this is exact replica of the slides that we had shared at that time. I told you that we'll cover algorithms and techniques for test case design. How are we going to do it? We're going to take software artifact, create models or structures out of them, and based on these models or structures, we're going to see techniques for test case design. And then, what are the structures that we see? We saw graphs as models of artifacts. We saw logical expressions. Then we only focused on the input space. And then finally, we focused on the syntax or grammar of the software artifacts. The test cases that we designed can be used for black box when it's based on requirements and can be used for white box when it's based on source code. And then these were the contents of the course that I presented to you at the beginning of the lecture series, right in the first week. So we did begin by introducing what software testing is, motivating it. Then I told you what are the process levels, what are the various set of jargons or terminologies that you will encounter in testing. After doing that initial bit, the main part of the course, the technical part of the course that we focused on was related to techniques and algorithms for test case design. We did graph-based testing. We did 2 kinds of coverage criteria purely based on graphs, structural coverage criteria, data flow coverage criteria. Along with this, I gave you a good amount of basic graph traversal algorithms, depth first search, breadth first search, strongly connected components, topological sort, and so on. And then what we did, we took graphs for source code, told you how to draw control flow graphs for various design entities. We took graphs for design elements, which were basically call graphs, sequencing constraints, and so on. We took graphs for specifications and then saw how to apply these coverage criteria on these graphs. Then we moved on to our next structure or model, logic-based testing. I introduced you to the basics of logic, predicates, clauses, and then we looked at coverage criteria based on logic. We saw the most useful coverage criteria. They were predicate coverage, clause coverage, and active clause coverage. Then we applied logic-based coverage criteria to source code, for specifications, and on finite state machines. We moved on, we looked at black box testing, so to say, where we focused only on the inputs and outputs, the space of inputs, and then we modeled the inputs and wrote test cases for coverage criteria based on various characteristics of the input domain. Then, in the past 2 weeks, I've been focusing on syntax-based testing, which focuses on the underlying grammar of the programming language or the software artifact, mutates or makes changes to that, and writes test cases to kill the mutants. Then, the course in the beginning, as I committed to you, I said you learn how to test object-oriented applications, how to test web applications, embedded software, GUI, graphical user interface, with or without using these criteria. We'll see the popular state-of-the-art issue, mainly like a survey of each of these categories. Finally, I'd like to end the course by presenting symbolic and concolic testing to you. So these were the course contents exactly as I'd given you in the beginning of the course. Now, I would like to spend some time looking back and thinking about what we have done. How does it relate to software development? Here is a popular model of software development that is still predominantly used even in this agile development world. It's called the Waterfall model, good old software development lifecycle model. Begins with requirements, goes on to do architecture and design. Then people write code. They also unit test their code. Then they put the things together and do integration testing, system testing, collectively called as testing phase. Waterfall doesn't really distinguish between the kind of testing that you do. Finally, after the software is ready, it's released and then maintained. In the waterfall model, you assume that requirements are baseline before you do architecture and design. You finalize the architecture and design before you write coding. And when you have begun testing, your code is more or less ready. There's not much going back, up and down, back and forth. That doesn't happen. Testing, as we saw in this course, is predominantly related to another software development lifecycle model called V model, which is what is given in this slide. So what does V model do? It takes the waterfall model as it exists here and sort of bends it to look at the other side. It focuses into testing. Splits the testing to see what are the various stages of testing that we'll go. Doesn't really particularly focus about release and maintenance. It's of course there, but the model that depicts the development life cycle lets go this part, release and maintenance. So it takes requirements, architecture and design, coding, takes testing and elaborates testing to let it span across other phases. This is how it looks like. So it always begins with requirements, like in waterfall model, followed by architecture and design, again like in waterfall model, followed by, I put this extra term where V model tries to focus on called low level design. So here we do system level design. Here we design into the system components, each individual things is almost like code. Then people do coding. Along with coding, they do unit testing of the code. After that, they do integration testing where they put together the software components and test it. And after they've put together and tested the software components, they put the hardware along with the software and then do integration testing. And then they put the whole thing in the system and do system testing. Finally, when the system is ready, they do what is called acceptance testing. We've seen all these terms before. What does the V model say? Let's look at these dashed lines with arrows in the V model. It says that integration testing is related to low-level design, system testing is related to architecture and design, acceptance testing is related to requirements. What is the legend for this dashed arrow? It says input for test case design. That is, if you want to design test cases for integration testing, where do you get data or inputs to design your test cases from? You get it from the low-level design. Similarly, if you want to design test cases for system-level testing, the source set of software artifacts that give you inputs to design your test cases come from architecture and design documents. Similarly, for acceptance testing, which is mainly black box testing, the source design for test cases come from your requirements document. What did we focus on in this course? We focused on the V model. In particular, we focused on how to use these various inputs from various software artifacts across the development life cycle to be able to design test cases that we could use for coding and unit testing. We could use for integration testing, system testing, or acceptance testing. This is again what I told you right in the first week. This is just a recap. These were the various types of testing. We discussed unit testing and integration testing just now. After that comes system testing and acceptance testing, which were all discussed as a part of the V model. We also discussed what is called beta testing. And I also told you at the beginning of the course that good old testing terminology says that there are two broad methods of testing, black box and white box. Black box doesn't look into the structure of the design or the code, assumes the design or the code to be a black box, designs test cases purely based on inputs and requirements. White box designs test cases by exploiting the structure of the design or the code. So black box testing applies for unit testing, integration testing, system and acceptance testing. White box testing also applies at unit testing, integration testing and systems testing phases. In addition, a whole set of other testing, usability, performance, load, beta testing, stress testing, they're all black box testing techniques. Back in the V model, they happen here. At system testing or acceptance testing, test cases for these kind of entities which test for non-functional qualities of a software come from architecture and requirements and design. We didn't look at any of those in this course. I'll tell you a bit of GUI but not the rest. We also discussed types of test activities. You begin with test case design followed by automation, execution and evaluation. What did we do in the course as far as types of activities are concerned? We focused a lot on test case design, basically criteria-based test case design, and I told you how to do automation and execution using the tool called JUnit, which applies for Java programs. This slide gives a very good summary of what we have done exactly till now in the course. So we took software artifacts, which could be source code, integrated source code, which is large code that includes all the modules put together, methods put together, classes put together. We took design elements, we took requirements either as documents or as finite state machines. Then we took inputs, details about inputs. Then we chose 4 different kinds of models or structures. We modeled these software artifacts as graphs, defined coverage criteria over graphs, 2 kinds, structural and data flow, and then saw how to apply it to source code, to design elements, and to finite state machines. After that, we took logical predicates which come from decision statements in the source code and from requirements or guards in finite state machines, and defined coverage criteria on logical predicates, clause, predicate, combinatorial coverage, active and inactive coverage criteria. We applied it again to test source code, finite state machine, and specifications. Then we focused on black box testing only on input spaces, defined criteria that partition the input spaces, and applied to test the software artifact based on the inputs. Finally, we did mutation testing, which was syntax-based testing. We saw how to apply it to source code, both within a method and at the software integration level. We saw how to apply it to design integration. Specifically, we saw one module on object-oriented design integration. Finally, we saw how to apply it to grammars for inputs. Along with this, we also saw a lot of the classical terms in testing that you would encounter in any old textbooks. Related to source code, these are the terminologies that I introduced you to: cyclomatic complexity, independent paths, basis path testing, decision to decision paths. I also told you in the context of white box coverage, statement coverage, branch coverage, loop coverage. We saw them as node coverage, edge coverage, and prime path coverage. Then when focusing on design integration testing, we learned about interfaces, types of interfaces, message passing, shared variable, and so on. We learned about what stubs and drivers are when it comes to integration testing. We learned various approaches to integration testing: incremental, top-down, bottom-up, big bang, and sandwich. When it comes to black box testing techniques, we learned about equivalence partitioning, decision tables, and boundary value analysis. In this process of lecturing to you about test-based design and criteria, we also saw a good number of formal models and languages. We saw the basics of propositional logic and predicate logic. I introduced you to finite state automata. We saw regular expressions. We saw context-free grammars. Of course, not very rigorously at a shallow level, but we did introduce them formally and saw results and examples about them. And we saw several examples of source code, several examples of design constraints like sequencing constraints, preconditions, postconditions. We saw examples of finite state machines for specifications and XML for in. What are we going to do now from week 10 onwards for the remaining 3 weeks? I'll introduce you to testing of web applications, object-oriented applications. Wherever applicable, we'll come back and look at how the coverage criteria we learnt applies here. I'll also introduce you, if time permits, to testing of embedded software, security testing, and about GUI testing. I'm not confident at this stage that I'll be able to cover all of them. We'll try to do as much as possible, but whatever we do, we'll do it rigorously and thoroughly. And I would like to spend some time in the last couple of weeks doing these 2 techniques, which are called symbolic testing or concolic testing, which have been there for the past 30-40 years, but they have surfaced now in a big way, and they give you a very niche set of algorithms to do path-based coverage in testing, and they also do the instrumentation for you. So this is where we stand, and this is what we're going to do. I hope this overview lecture was useful for you to sit back and reflect where we are in the course, what we did till now, and what are we going to do from now on. So next week when I meet you, the first video will be on testing of web applications. Thank you.